Okay, my name is Tankiso. I'm presenting my assignment MIT805. This assignment is about analyzing the big data that was collected online. Specifically, this is the New York City transport data. First, I'll open the README file so that it can guide us on what we need to do. Dependencies that we'll need for this project to work is run in Python, and these are the libraries that we need to install. NumPy, bootcore, request per arrow, meteostat, PySpark, and matplotlib for visualizations. The data is downloaded from this site, which is the official TLC record triptada, and we also additionally included weather data, which is downloaded from meteostat. To run the project, we only need one file, which is the NYC Transport Map with Visualization Notebook, and it can be downloaded and run locally, or you can run it on Google Colab, which is where I'll be running it from. This is the notebook, so it will do everything from downloading the data from the New York City transport site. Additionally, it will also normalize the data, run MapReduce functions, and then finally visualize the data. To open this data in Google Colab, you can just click at the bottom that says Open in Colab. I've already opened this, and this is what you will see when you open the notebook. It runs smoothly. All you need to do is just click the Run All cell, click, and then run all the cells. I've already clicked, as you can see. The first section will handle the downloading and installation of packages automatically. As you can see, they already have downloaded here and installed. This is the website that we get data from, and these are the data sets that we explicitly say we want to download. This is for higher vehicle, high value, yellow taxis, and for higher vehicle. This is the function that we use to download, but the one that actually downloads is the loop here, which runs through the years, which is 2023 to 2024, and runs throughout all those three data sets. As it downloads, it will show the progress for all the files that have been downloaded. And after download, we have this function that will run through the downloaded data, and then it will give you how much data you have downloaded. As you can see here, we have 72 files, and they are all totaling to 12.39 gigabytes. Additionally, we also download the weather using the latitude and longitude of New York City so that we can have a uniform data. And this is the website that we're getting the data from. Similarly, after the download of the weather data, they will also show the summary of the data downloaded, 24 files here. And here we are in normalization part. Here there is no such thing that we are doing, except that we want to make sure that our data through the three data sets have normal or have a similar data. For example, the columns that we're going to use have to be the same, have to have the same data type. We also additionally do away with columns with rows that have null values in the required columns, which is the pickup locations and drop-off locations. So this is just the confirmation of the normalization. After normalizing, we are going to do map reduce functions. As we can see here, we're going to select zone our pickup, which is we're going to average the pickups that happened throughout the hour for all the three data sets. Or at the beginning here is the map function that only select the required columns, and this will be the data set and year and month tag, and then the actual columns, which is pickup, location, and time. The reduction will be grouping by the data set, years and month, and then we are going to be counting those. This is a similar thing to what we've just done. It's still a map reduce function. Additionally, we are going to convert the weather data into the US format, which is going to be read by the PySpark. It was giving errors or on the file on the data that was that we got from MIT805. This is the start of our visualization part. The first visualization is as you can see, this is the weekly pickups to show total pickups during the week per hour. As we can see here, the busiest times will show the yellow color, and here we can see that the rush hour starts at from 8 a.m. and goes all the way until 6 p.m. A bit different on the weekend, as we can see that the rush hour doesn't stop at 8, it goes all the way until 11. This is the pickups versus the weather conditions. As we can see here, we have precipitation, and below we have wind, but both of these don't have much Another visualization that we have is the monthly pickups running through all the data we have, which is from January to December, from January 2023 to December 2024. And as we can see, vehicle for high value, which is the one with the orange graph, is miles above the rest of the other operators, meaning there's an opportunity for these other operators to also grow. The last visualization is about top 5 boroughs that have the most pickup or the most text strips. We have selected the top 5 boroughs, and then make a graph, a donut graph that shows the distribution of the trips per data set or per data or per text operation. For example, here in Manhattan, as we can see, we have 26% belonging to the yellow text, 73%, which is a huge chunk, going to high value vehicles. As we can see throughout the other boroughs, they are also green, which means that they are all dominated by vehicle for high value. Thank you. That will be the end of the presentation. Thank you.